Assalamualaikum and good morning. Bagi agama Islam, kita mulakan dengan surah Al-Fatihah. Okay. Today we continue our discussion still in the topic of forecasting. The next technique in the time series analysis that we're going to discuss for this morning is exponential smoothing. Exponential smoothing is form of weighted moving average and the weight they assign to the data will decline exponentially, and the most recent data will be weighted most compared to the older data. And in the exponential smoothing, we using an alpha value that range from 0 to 1. And this alpha value is subjectively chosen by the forecaster. And the advantage of the exponential smoothing is only requires a little record of the past data in order to use this forecasting technique. And so this is the formula for the exponential smoothing. For example, we would like to forecast the demand, the customer demand on October, November. On November, let's say we're going to forecast the demand on November. So F November equal to F T is the new forecast. So T is new forecast minus by 1. So we need to information about the previous forecast in October. So the forecast in October plus with the alpha value multiply with the actual in October minus by forecast in October. So based on this formula, we can forecast the customer demand in November. So for example here, let's say the forecast demand is 142 in October, and the actual demand is 153 in October, and we're using a constant alpha value of 0.2. We're using the alpha value at 0.2. So let's say we're going to forecast what is the forecast demand in November. So we need this information to be included in the formula of exponential smoothing. So 142 plus 0.2 multiply with actual demand minus by forecast demand in the previous month. So we get here 144.2 or equal, or we round up to the 144. So this is the formula and how the exponential smoothing calculating the forecast for the next coming month. Okay. Choosing an alpha value, the objective is to obtain the most accurate forecast no matter the technique. we generally do this by selecting model that give us the lowest forecast error. Forecast error equal to actual demand minus by forecast value to get the deviation. What is the deviation or error of our forecast? Okay. Let's say we do the exponential smoothing first before we go to the measuring the error in the forecast.
Tolong
Yeah.
record sir.
Sorry?
Tolong record.
Hari tu saya rekod tak masuk lah. Macam mana? Sekejap ya, saya cuba saya terlupa lah. Hari tu saya rekod yang kelas satu lagi tu tak masuk pula. Okay, alright. Let me do the exponential smoothing analysis or calculation for the for forecasting the example data that we have in the slide. So let's say we have information about the actual demand from month January to the August. And based on the exponential smoothing that we have here, we are using alpha value of 0.1. Alpha value 0.1. So the first step is to identify what is the forecast for the month 1 or January. What is the forecast in month of January or 1? Confusing, right? So better I change this. This will be February, March, April, May, June, Okay. Let's say we need to forecast what is the demand in February. So for the first step, we need to know what is the forecast for the month of January. In the data, to start the exponential smoothing, sometimes we didn't have any information to start with the exponential smoothing information about the forecast. So let's say we didn't have any information about the forecast in January. So the rule of thumb here, the forecast in January will be equal to the actual demand 180. 180. Let's say from the data that we have, there are no information about the forecast in January. What is the forecast in January? So we didn't have any information about that. So the first step is to assume that the forecast in January is equal to actual demand, where we using the naive approach technique in the forecasting for the forecasting in the January. So, but if we have information about the forecast in January, we be used for the next forecast in February. The example data that we have in the slide, the data provide the information about the forecast in January of 175 unit, right? So based on this data, we're going to forecast what is the forecast demand in February. In order to do that, we will include all the information in the formula of exponential smoothing forecast. First, we need to include the data of forecast in the previous month. It is a January. So here will be 175. 175, the forecast in January. Plus with the alpha value 0.1 multiply with the actual demand in January 180 minus by forecast in January 175. So for February, the forecast will be 175.5. Okay, boleh ya? Boleh dapat ya? Boleh. Katakanlah kita nak buat forecast pada bulan Februari. Jadi apakah maklumat yang kita perlukan? Maklumat yang kita perlukan adalah forecast dan actual demand pada bulan sebelumnya, iaitu pada bulan Januari. Kan? Pada bulan Januari. Jadi 180 tersebut kita akan masukkan, sorry, 180. Kita akan masukkan dahulu 175 actual demand ditambah dengan nilai alfa 0.1 darab actual demand tolak forecast data pada bulan Januari tersebut, maka kita akan dapat nilai sebanyak 175.5. Jadi kita akan ulang proses ni sehingga habis. Baik, sebelum tu sekiranya kita tidak diberi maklumat berkaitan dengan apakah forecast pada Januari. Kita tak diberi maklumat apakah forecast pada Januari. Jadi kita akan membuat andaian bahawa forecast pada Januari adalah bersamaan dengan actual demand pada Januari. Yang mana kita menggunakan pendekatan naive approach. Sekiranya maklumat tak diberilah, kan? Sekiranya maklumat diberi, kita akan gunakan maklumat yang disediakan tersebut. Jadi dalam case data pada slide tersebut, maklumat berkaitan dengan forecast Januari diberi sebanyak 175. Jadi kita gunakan nilai tersebut 175. Baik. Seterusnya. Katakanlah di sini kita menggunakan nilai alpha value yang berbeza. Let's say there's a second example of exponential smooth thing. We using alpha value of 0.5. The same procedure, the same formula for the exponential smooth thing will be applied to forecasting the data, forecasting the demand based on this data. So the next discussion is on the measuring the error. So we'll be back on to the slide and discuss about the error. Okay. Forecast error. There are numbers of techniques that can use to measure the error in the forecast. Mean absolute deviation, mean square error, and also we have mean absolute percent error. So for discussion of forecasting in the inventory management, we only discuss on these three techniques that used to measure the error. So let's say we're using the data that we discussed in the exponential smooth thing. For the forecast with the alpha value 0.1, for the first step in measuring the error, we need to know what is the deviation. If we're using the mean absolute deviation, we need to find what is the absolute deviation for alpha value of 0.1. For the quarter one here, also this is the quarter, not the month. Okay, for the quarter one here, we have deviation, absolute deviation of 5. How do we get the 5? We just actual 180 minus by forecast 175. So we have 5 apa ni unit. Okay, so we have absolute deviation of 5 unit here. For the quarter 2, the actual demand is 168 and the forecast alpha value of 0.1 is 175.5. So we have the absolute deviation of 7.5. We have 7.5. We ignore the signs of minus here. The negative, sorry. We ignore the signs of negative value here. Since we have the lower actual demand minus by 175, the answer should be negative 7.5, right? But to calculate the to determine the mean absolute deviation, we need to identify what is the absolute deviation, where we ignore the sign of negative value. So we assume that all the value of absolute deviation will be in the positive integer. So here, we total up all the absolute deviation and we have 82.4 We have 82.45. And same with the alpha value of 0.5, we will repeat the process calculating the absolute deviation. And the total for the absolute deviation for alpha value of 0.5 is 98.62. So what is the mean absolute deviation we have here for the exponential smoothing based on mean absolute deviation? For the alpha value 0.1, we have 10.31 value of mean absolute deviation. And alpha value of 0.5, we have 12.33. So based on this finding of the mean absolute deviation, we need to decide which forecasting technique or which alpha value that is more reliable, that is have a low forecast error technique. So in choosing or in determining which one of the forecasting technique with the alpha with the more reliable alpha value used in the exponential smoothing, so we decide to choose the lowest mean absolute deviation with the value of 10.31 and 10.31 with the alpha value of 0.1. So we can conclude that based on the mean absolute deviation, exponential smoothing with the alpha value 0.1 will be chosen as the forecasting technique because the mean absolute deviation provide the lowest value compared to the exponential smoothing with alpha value 0.5. Baik, kamu boleh tulis apa saja untuk kesimpulan berdasarkan mean absolute deviation tersebut dan pastikan kamu masukkan nilai forecast error yang terendah dan kenapa kamu pilih, kan? Apa kamu kena nyatakan kenapa kamu pilih forecasting teknik tersebut dan berdasarkan yang manakah memberikan nilai mean absolute deviation yang terendah. Okay, ada soalan? Any question regarding to the measuring error using the mean absolute deviation? Ada soalan tak? Okay, we proceed the next technique in measuring error in the forecast. Mean square error. Mean square error. So, mean square error, we square the value of deviation that we have. We square the value of deviation. For example, that the square value for the absolute deviation is for the quarter 1, 5 multiplied with 5. So we have 25. 7.5 multiplied with 7.5. So all the total value for the square absolute deviation here will be used in measuring error using the technique of mean square root. So the total of the alpha value will be alpha value with the square forecast error the 1526.54 will be divided by n value of 8, and we have 190.82. Compared to the alpha value of 0.5, we have 195.24. So again, we need to make the conclusion based on,
Sir,
yeah,
sorry to interrupt. Macam mana kita dapat yang 1526 tu?
macam mana kita dapat? How do we get 1506.54?
Yes, sir.
Okay. Okay, using the short form, MSE is mean square error. So the first step is to identify what is the deviation of the forecast from the actual demand. So we do the minus the actual demand with the result of forecasting. Here we have 5 unit, and in the quarter 2, so this is the quarter, not the month, right? So this is the quarter, not month, and we change back. Okay, so in the quarter 1, we have duration of 5. In the quarter 2, we have 7.5. So in the mean square error, we need to find the square value of the deviation. So here we have 5 multiply with 5, right? So we have 25. 7 multiply with 7.5. We have 56. So here we have the mean square error. Let's say for the mean square error, value of deviation for the mean square error in the quarter 3, 15.75, we have 248.06. How do we get this answer? By square the data of deviation. 15.75 multiply with 15.75. Okay. Next, we total up all the data in the mean square. So we get the total value of mean square error here, 1526.54. Based on this value, 1526.54 divided by the number of n, the numbers of data that we have. Data here we have the data. Padam pula. Okay. 1526.54 divide by the number of data that we have here. We have 8 quarter. So we divide with the 8 quarter here. So we have the value of the mean square error. The value of mean square error. MSE. Okay. Padamlah yang ni dulu kan. Nanti kamu confuse. Padam yang ni dulu. Okay. So we have the answer for the mean square error with 190.82. So let's say we do again for the alpha value of 0.5, measuring the mean square error here. MSE, equation for MSE square MSE. Okay. So 5 multiply with 5, we have 25. 9.5 multiply with 9.5, we have 90.25. Right. So 13.75 multiply 13.75, we have 189.0.6. Okay. So we repeat this process to get all the error under the mean square error. So here we have the total for the, let's say we choose the total sum here, 100. So we have the total mean square error here, 1561.92 will be divided with 8 quarter, right? To get the mean, by 1561.92 divide by 8. So we have 195.24. So this is the mean square error with the alpha value of 0.5. Is it clear, Danusha?
Yes, sir. Clear.
Okay.
Thank you.
Can we proceed for the next measuring the error in the forecasting technique? So we left the Excel 5. Back to the slide. Where is the slide? Yeah. Okay. So based on the mean square error again, we found that the mean square error with the alpha value 0.1 have the lowest error with the value of 190.82. So based on this finding also, we choose exponential smoothing with the alpha value 0.1 compared to the exponential smoothing technique, forecasting technique with alpha value 0.5 that provide higher forecast error compared to the alpha value of 0.1. So the next technique in measuring the error in the forecast is we using mean absolute percentage error. We using mean absolute percentage error. Where based on we using this data of deviation, but in the value of percentage, with the value of percentage from the actual. So how do we get this answer? Back to the Excel file. Stop sharing. Bukan. Mana satu? Mana dia dah Excel file? Oh yang ni. Atau saya dah rabun dah ni kan. Kecil-kecil sangat. Kena tengok dekat-dekat. Okay. Let's say we using the MAPE, mean absolute percentage error. Mean absolute percentage error. The first step is to find the deviation of the actual demand and the forecast. The actual demand and the forecast. So MAPE, we have here MAPE, mean absolute percentage error. So in the MAPE, the first step is to find the percentage of the error from the actual demand. Percentage of error from the actual demand. So the deviation here is the error in the forecast. So this error 5 divide by actual demand. Divide by 5 divide by actual demand 180, and we convert it to the to the percentage value. We convert it to the percentage value. Okay, so we have the percentage value of 2.78%. And for the second, let's say for the second error, 7.5 divided by actual value, actual demand here 168. So the percentage value is 4.46. How do we get the percentage value? Just multiply with the 100%, right? So we get the percentage value. Boleh tak? Boleh eh? Macam mana kita dapat ni? Saya ulang sekali lagi lah kan? Ulang sekali lagi. Okay. Macam mana kita dapat ni? Maksudnya macam mana kita nak dapat percentage value? berdasarkan deviation 5 bahagi dengan actual demand. Berapa actual demand? 180 kan? 180. Actual demand 180. Oh, actual demand 180. Jadi kita akan dapat nilai percentage 2.78. Macam mana kita dapat nilai percentage? Sebab saya dah set gunakan Excel ni mudah kan? Gunakan Excel ni mudah. Kita set pada Excel tersebut untuk dapatkan value percentage. Tapi macam mana kalau kita tulis atas kertas? Kita kena darablah dengan nilai 100 untuk dapatkan nilai percentage kan? Kita akan darab dengan nilai 100 untuk dapatkan nilai percentage. Bagi contohnya di sini, katakanlah kita dapat 5 kan? Kita di sini 5 bahagi dengan saya dah set dah semua percentage. Kita ambil kat sini lah, sel ni tak ada percentage kot. Okey. 5 bahagi dengan 180. Darab 100. Kan? Kita akan dapat 2.78. Saya akan set titik perpuluhan di sini dengan nilai 2 titik perpuluhan. Jadi kita dapat samalah 2.78. Boleh ya? Boleh ya? Okey, 7.5. Let's say 7.5 7.5 divide by actual demand 1.68. So the percentage value error, the percentage value, the percentage value in for the MAPE is 4.46%. Okay. Jadi kita akan buat semua yang sama di sini. So we repeat this process to find what is the error in the percentage. So divide by actual demand. And the next step is total up all the percentage that we have. Apa dia dapat macam tu? Sama je kan? Okey. Dia tak. Okay, so the total percentage, the mean absolute percentage error, total of error in the percentage is 44.75. So this value will be divided with the 8 quarter here, 44.75 divided by 8. So we have the percentage, mean absolute percentage error for our forecasting with the alpha value 5.59. 5.59. So this is how we analyzing the forecast error using the mean absolute percentage error. Boleh ya? Boleh? Boleh tak? Yang lain? Ada soalan? Boleh ya? Okey. Kita pergi ke mana? Slide. Confused lah. Mana satu slide saya tadi? Mana PowerPoint? Okey, ni dia. So, based on this error, using the MAPE technique, we found that the alpha value, the exponential smoothing with the alpha value of 0.1 provide the lowest percentage error of 5.59%. So we decide to choose the exponential smoothing with the alpha value of 0.1 to be the best forecasting technique, or to be the more reliable forecasting technique compared to the exponential smoothing with the alpha value of 0.5. Baik. Jadi kamu jangan silap pula bila tunjuk contoh ni semua menggunakan teknik exponential smoothing untuk kira error. Sebenarnya error ni boleh kita apply untuk ukur bagi setiap forecast teknik yang ada, kan? Kita boleh ukur error ni pada membuat perbandingan antara teknik moving average dan exponential smoothing. Kita buat perbandingan antara output daripada weighted moving average dan exponential smoothing, ataupun kita nak compare dengan ketiga-tiga teknik yang ada. Boleh kita gunakan teknik pengukuran ralat pada forecast tersebut. Okey. Cepat tak habis ni? Pukul berapa dah? Lambat saya hari ni start. 9.42. Okay. The next technique of time series analysis is, this is associative forecasting technique, and using the linear regression analysis, where we need to find what is the value of y equal to a plus b x. Oh, kan saya nak cerita ni. Sempat ke tak sempat? Sempat jalan. Okay, I think we finish our class and for today, and I will continue this forecasting technique on the linear regression analysis based on this example. So any question before we end our online class? Banyak lagi. Any question? Okay, ada soalan Tarikh. I will update the information about the quiz, the date of quiz and midterm exam. Midterm exam. Not as a midterm exam, we change the name to the test 1. So we have quiz 1, quiz 2, test 1 and test 2. Okay, so I will update the date and time in the WhatsApp group. So be alert on the information in the WhatsApp group. Okay, bagi yang beragama Islam, kita sudahi dengan